All aboard, the basics of trains. Have you ever wondered how trains work? It's pretty fascinating. Trains have been a crucial part of transportation for centuries, evolving from steam-powered engines to the modern electric and diesel trains we see today. Trains are like giant puzzles, with many parts working together seamlessly. Each component plays a vital role in ensuring the train operates smoothly and efficiently. At its core, a train is a series of connected vehicles. These vehicles are designed to work in unison, creating a long, flexible structure that can navigate tracks and curves. These vehicles, called carriages or cars, carry passengers or cargo. Passenger trains are equipped with comfortable seating, amenities, and sometimes even dining cars, while freight trains are designed to haul heavy loads of goods and materials. The entire assembly travels on a fixed track. These tracks are meticulously maintained to ensure safety and efficiency, guiding the train on its journey. This track guides the train and ensures a smooth journey. High-speed trains, in particular, rely on precision-engineered tracks to achieve their incredible speeds. Trains come in all shapes and sizes, from sleek, high-speed bullet trains to massive freight trains. Each type is designed for a specific purpose. Some trains transport people, while others haul heavy freight. Urban commuter trains help reduce traffic congestion, while freight trains are essential for moving large quantities of goods across long distances. No matter their purpose, all trains share some common elements. These include the locomotive, which provides the power, the carriages that carry the load, and the tracks that guide the train. These key components include the locomotive, the carriages, and the tracks. The locomotive is often the most complex part, housing the engines and control systems. The locomotive is the powerhouse, providing the force that moves the train. It can be powered by electricity, diesel, or even steam in historical trains. The carriages, linked together, carry the load. They are designed to be easily connected and disconnected, allowing for flexibility in train length and capacity. And of course, the tracks provide the pathway for the train to follow. These tracks are laid out in a network that spans countries and continents, connecting cities and regions. This intricate system of interconnected parts allows trains to transport people and goods efficiently across vast distances. The coordination between the locomotive, carriages, and tracks is a marvel of engineering. So next time you see a train, take a moment to appreciate the complexity and ingenuity behind its seemingly simple movement. From the powerful locomotive to the carefully maintained tracks, every part plays a crucial role in making train travel possible. The mighty locomotive, the engine that makes it go. Trains have been a crucial part of transportation for centuries, and at the heart of every train is its locomotive. The locomotive is the heart of the train. It's the powerhouse that drives the entire train forward, making it possible to transport goods and passengers over long distances. It's the engine that makes everything go. Without it, the train would be nothing more than a series of stationary cars. Think of it as the muscle behind the movement. Just like muscles in a human body, the locomotive provides the necessary force to move the train. Locomotives come in different types, each with its own way of generating power. This diversity allows trains to operate in various environments and meet different needs. The two most common types are diesel locomotives and electric locomotives. Each has its own unique characteristics and advantages. Diesel locomotives are like giant trucks. They are robust and can operate independently of external power sources. They have powerful diesel engines that burn fuel to create energy. This energy is then converted into mechanical power. This energy then turns the wheels, propelling the train forward. The process is similar to how a car engine works, but on a much larger scale. Electric locomotives, on the other hand, get their power from electricity. They rely on an external power source to function. They draw electricity from an external source, like overhead wires or a third rail. This electricity is then used to power electric motors. This electricity powers electric motors, which then turn the wheels. The process is highly efficient and produces less pollution compared to diesel engines. Both diesel and electric locomotives have their own advantages. Diesel locomotives are versatile and can be used in remote areas without electrical infrastructure. Diesel locomotives are self-contained and can operate on tracks without electrical infrastructure. This makes them ideal for long-distance travel in areas where electrification is not feasible. Electric locomotives, while needing an external power source, are generally more environmentally friendly and efficient. They are often used in urban areas where electricity is readily available, reducing the carbon footprint of train travel. Diesel power fueling the journey. The journey of a diesel locomotive begins with a simple yet crucial process, refueling. Diesel fuel is the lifeblood of these powerful machines, enabling them to traverse vast distances with efficiency and reliability. Let's take a closer look at how diesel locomotives work. These mechanical marvels are a testament to engineering ingenuity, combining power and precision to move heavy loads across the country. They use a type of internal combustion engine, much like the engine in your car or a truck. However, the scale and complexity of a train's engine are far greater, designed to handle the immense demands of rail transport. The engine burns diesel fuel in cylinders. This process begins with the precise injection of diesel fuel into the engine's cylinders, where it mixes with air and ignites. This burning creates hot, expanding gases. These gases are the driving force behind the engine's power, expanding rapidly to generate the necessary force. These gases push pistons, which then rotate a crankshaft. The movement of the pistons is a critical step, converting the energy from the expanding gases into mechanical motion. The rotating crankshaft is connected to a generator. This connection is vital as it allows the mechanical energy to be transformed into another form of energy. The generator converts the mechanical energy from the crankshaft into electrical energy. This electrical energy is then used to power various systems within the locomotive. This electricity powers electric motors, which are mounted on the axles of the locomotive. These motors are the final link in the chain, converting electrical energy back into mechanical motion. When the electric motors receive electricity, they start to spin. This spinning motion is what ultimately drives the locomotive forward. This spinning motion turns the wheels of the locomotive. The wheels, now powered by the electric motors, begin to turn, propelling the train along the tracks. The wheels grip the rails and the train starts to move. This gripping action ensures that the train maintains traction and stability as it moves. It's a fascinating chain reaction, all starting with the burning of diesel fuel. Each component works in harmony, showcasing the incredible engineering that powers our railways. Electric avenues trains on a different current. Electric locomotives offer a cleaner and quieter alternative to diesel. Instead of generating their own power from fuel, they draw electricity from an external source. This source can be overhead wires called catenaries, or a third rail running alongside the tracks. A device called a pantograph, mounted on the locomotive's roof, connects to the overhead wire or third rail. The pantograph draws electricity from the source and feeds it to the locomotive's electric motors. Just like in diesel-electric locomotives, these electric motors are connected to the wheels. The flow of electricity makes the motors turn, rotating the wheels and propelling the train forward. Electric locomotives are known for their smooth and efficient operation, making them a popular choice for passenger trains, especially in urban areas.